All right, so today we're going to start into chi-square tests, specifically, for God's sakes. Chi-square test for independence is what it's called. Or, I mean, goodness of fit test. Goodness of fit test. And my pen, of course, is not going to work because, obviously, of course. One moment, please. All right, so like I was saying a minute ago before I was rudely interrupted, it's a goodness of fit test. It is a chi-square test. Chi-square, our guy chi-square, remember him? Now, the cool deal about this is super duper easy. So, here's the game. I work at the flower shop. Okay? And I fully believe that this pot of tulips, there's this big bin of tulip bulbs, and there's literally thousands of them in here. Thousands, okay? Thousands of them. I am firmly believe that 20% are red. 30% are yellow. Oops, red, yellow. 10% are orange. 30% are purple. 40, 70, 10% are white. Sure. Okay, that's what I believe. Why? Because I ordered them that way. I don't know, because that's what they're supposed to be. Whatever. Wait, that sounds like H naught, bro. I know. So H naught is always, this model is a good fit. Or this model is true. You can think it that way. But we normally say it's a good fit. Okay? That's the idea. This is the model. And H1 is, of course, it's a terrible model. It doesn't fit at all. Okay? That's it. Alpha 0.05 as per usual. All right, a couple things to remember. If you'll recall, your chi-square number, your chi-square distribution always kind of funky like that. It's always going to be an upper-tailed test. Always, always. Always. So keep that in the back of your head. Okay? So the way this works is, listen, we are going to do the sum of the observeds minus the expecteds squared divided by the expecteds. Take the sum of that. Okay? What do I mean? Well, I'll tell you in a minute, bro. Done. Okay, that's what I'm going to do. Okay, this will be our chi-squared number. And then we're literally going to find out how much area is out here. This is your p-value. Are you with me? Okay, and so we're going to do that in just a minute. It's that easy. Now, let's say we put an exact number here. So instead of saying thousands, let's throw an actual number at it. Just say it's 2,000. That's hot. So if you are good at math, you realize that the reds, that's stupid. That 20% of 2,000 is 400. You expected 400. You go count. You observe, I don't know, let's say you observed 350. Is that bad or good? It's different. I don't know. Are you probably going to get exactly 400? Probably not. Probably not. Now, 30% of 2,000 is 600. I counted, Groom, and I got 590. Okay, cool. 10% of it's supposed to be orange. So that is 100. Well, I got 140. Okay, interesting. 100. I don't know what that is. 100 box, whatever. 140. Purple rain. Should be 600. We got 650. Weird. Now the last one should be 100. Dang it, you dirty hippie. For a grand total of 1,000, am I right? Am I right? I feel like I'm right. That's 1,000. Oh, Chelsea lost to Man U. Hey, whatever. Here. Now, 350 plus 590 plus 140 plus 650 is, good Lord. Oh, 1730. Right, yeah, that's right. So we only see 7. Mr. Groom has had a problem here. Well, a couple problems. For the love of Mike. And we got 70. Groom, how do you know you got 70? Because I took 2,000 bulbs out, sir. Is that what I said? Oh, no, I did not. Oh, I did not. Is that right? 350 plus 590 plus 140 plus 650 plus 1. What the Sam Hill's going on here? Mr. Groom sucks at math, apparently. 20% of that is that. And 30% is 600. And then 100. And then 600. Well, there's your problem, sir, you dumbass. These should both be 200. So for those of you that were screaming at me the whole time, I'm sorry. I suck at math. Why are you our teacher? Because you suck. I'm sorry, I don't know what to tell you. 270 would be here, I guess. Could I change the others? Yeah, I guess I could, but whatever. This is going to work just fine. Hey, my pen is broken. Woohoo. 270. Yay. Okay, so what I see is I see a column of observeds and a column of expecteds. So what Groom's going to do is I'm going to copy that table. Now, honest to God, I would not have done it by hand. You know what I'm saying? Because I've got a calculator. I've got computers. Computers are the bomb. So if I did color, just to keep, again, just the same picture here. And expected and observed. And then we had wet and widow and orange and purple and white. 400, 600, 200, 600, 200. And then we went in and actually counted, and we got 350 of these, which is a little odd. 590 of those, which is pretty what you'd expect. 140, a little odd. 650, that's a little odd. 270, that's borderline ridiculous. Oops, that would be a big number. And then 270, as I said. Now, here's what's going to happen. Boom, ta-da. Ta-da, 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 ta-da. So what I'm going to do is I'm going to go equals, parentheses, observe minus expected squared divided by expected. Am I right? And then I'm going to paste that puppy down. And then I'm going to add those up. Equals the sum of these guys. Done. And I get that big god-awful number. That number, friends, is this spot right here. The question is it far enough over so this p-value is less than 0.05? That's the question. And so what a guy's going to do is equals chi-squared dot dist. Now, we can do this a couple different ways. I'm just going to do it this way first, as you can see it. Now, what's our degrees of freedom? We had 1, 2, 3, 4, 5 colors, 5 minus 1, 5 categories minus 1, 4 degrees of freedom, and cumulative. Oh, Groom, what'd you forget to do? We said it's an upper tail, you moron, so you need to do 1 minus. Ha-kaboom! There's your p-value. Hey, that's less than 0.05. What did we do? Well, we reject H0. What does that mean? That means this thing here is a terrible fit. It's a terrible fit. That outfit that we bought our tulip bulbs from, terrible people. They can't count. They lied to us. You know, whatever. I don't know. That might be a little extreme. Okay, but yeah, whatever it is we're doing, it's not useful anymore. Okay? Listen. in our country. We need some data. We need real data. Let's go on the internet because that never lies to us. Distribution. Come on, you dirty hippie. Oh, you dirty hippie. Oh, no. No. You filthy pig. Distribution of hair color USA. Let's say 50. Let's go. Let's just make this a nice even 60% brown. 60%. You dirty, rotten, no good scoundrel. Why aren't you working? Well, it's always something in life. It never goes right. All right, so what we're going to do is we're going to type it into our stupid thing over here. So Groom is going to type on a new one here. Hey, we want to test to see if this proportion, so H naught is, this is a good model for hair color in the US. Obviously, China would be different, obviously. Well, one would think anyway. This is not a good model. That's it. That's it, babe. Now, what do we got? Well, we got our different colors. So we get brown, blonde, red, black. Oops, come back, come back. See that? Nice. So let's do 60, 30. Now let's do 50, 30. That's 80, right? 15 and 5. How about that? 50, 30, 15 and 5. 50.5, 0.15, 0.05, and 0.2. Is that right? 0.25. No, 0.3. Again, this has to equal 100%. If you haven't figured that out yet, we got a problem. I don't have to tell you. Ta-da! Nice. Now, let's go out and sample. We're going to go out and sample 600 people. Right? So, what would your observed be? Insert. So, observed and expected. Well, now listen, out of 600, I expect 300 to be brown. I expect 90 to be blonde. Oops, 90. I expect 30 to be red, and I expect 180, is that right? 180 to be black. And let's just double check the sum of that just for a good time, huh? Because the sum here had better be 600. Oh, it is. Yay. So I go out and I look, and I get 320. I get 100. I get 20. I get 160. Done. Okay, yay, there they are. Now, that's obviously different. Of course it's different. Is it enough different to cause an issue? I don't know. That's why we do the test. Boom. Squared divided by expected. Done. Paste that puppy down. And then copy this over for a good time, huh? Because it's still the sum, right? Like, whoa. Groom, on the last one, we got a chi-square of like 50 or something. That was way over there, but I feel like 8's not that far over. You mean it's not weird enough? No, probably not. So equals 1 minus chi-square dot dist 8, comma 4 hair colors, so comma 3, comma 1. 0.046. Dude, it is just barely significant that model that we said, this 50, 15, 5, and 30, it's off a skosh. It's off a skosh. Okay. Now, why is that? Is it possible we didn't sample enough people? Possibly, right? If you take a small enough sample size, weird things happen. Am I right? And so you got to be aware of that going into this thing. Okay. So, whatever. We're just going to do the problems we're told to do, but be under the lookout that if you took say you took a sample of 6,000 people randomly selected and you got that kind of a number, you're like, oh, guess what? That's a bad model. If it's out of like 100, you're like, well, I bet if you took a bigger sample, it would be less variable, right? But again, it's just the same principle every stinking time. Hey, we go at the flower shop. Kind of flower. Nice. And what about them, groom? I don't know. Roses are red, violets are blue. Tulips. Daisy. Carnation. Whatever. And so listen. We are given to understand that we sell our flowers in this sort of a situation. It's a 7 to 2 to 4 to 3. Oh, shoot. To 2 relation. Why did that show up? That's freaking bizarre, bud. So there's 5 things here, and that's our ratio. If you look at it, that's 5, 9, 11. There's 18 parts there. Is that true? You with me on this? So 7/18 of all sales then would be roses. Does that make sense? Because it's 7 parts roses. So roughly 39% of our flower sales, you see, would be roses. All right. Now, let's do a sample. Let's do it out of 5,000 roses, Mr. Chrome. Let's do 5,000 flowers. Okay, 5,000 flowers equals. So we're gonna go and we are going to take 5,000 flowers and we're gonna see what's up. So as I said, 39% roughly times 5,000. Oops, that's one too many zeros, groom. That's roughly 1,944.44 roses is what we should sell. Okay, you with me on this? Now, for violets and carnations, they are the same. So what does that mean? Well, it means it's going to be equals 2 divided by 9. You with me? Or 2 divided by 18, rather, which is 1/9, times 5,000. What in the Sam Hill? Times 5,000. And we get, what are you doing, bro? Oh, not equals. I'm stupid. What are you doing, bro? So 555.55. Whatever. Okay, cool. Now, groom, what about carnations? Well, they better be the same because it's the same parts, yes? And what about tulips? Tulips are twice as much, so equals 2 times 555.55555. Ta-da! There it is. And then you could do it 2 different ways here. You could do 3 divided by 18, which is what I will do, or you could subtract. So equals 3 divided by 18 times 5,000. Oh, cripes. Times 5,000. Darn it. Darn it, you hippie. Oh, darn it. 833.333. As you can see, it's 5,000. Yes? Nice. So these are our expected. Is it possible to expect a decimal? Yes. It's just like saying that the average family has 2 3/4 dogs or whatever, 9.5 chickens or whatever it happens to be. Now, let's go out and ask some people. So I'm going to go out and ask 5,000. Well, so I'm going to look at 5,000 sales come through. And out of these 5,000 sales, I sold 1,900 or 2,000 roses, and I sold 500 violets, and 1,100 of those, and then 850 of those. Watch this, dog. And so the other 550 flowers must have been those for a total of 5,000. Are you with me? So equals, again, I would have just gone out and observed. How many did we actually sell? This is what we actually sold. This is what we expected to sell. And any difference between them is only there because our expected value is calculated based on our model. And if our model is no bueno, then we're going to find that out. Look at that. That's a tiny little chi-square number. So 1 minus chi-square dot dist. And that comma, there were 1, 2, 3, 4, 5. So 4. 5 minus 1 is 4. And so you get 0.10. Fail to reject, which means what? Hey, this is a pretty good model. We do sell our flowers in approximately this relationship to one another. Okay? That's it. That's the goodness of fit test. There's not a whole lot to it. You'll understand as we get going into it. Definitely do it using Excel, like I just showed you right here. Or rather, Google Sheets. You know what I'm saying. It's the same thing. And just type your data into there. Write on your paper, H naught, blah, 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 H1, blah, 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 blah. Do the math on there. Heck, I don't care. If you want to write on here, you can do it on H naught, da, 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 H1, da, da, da. Write your p-value right here, p-value, da, da, da. If you just want to use Excel, that's totally fine. Or Google Sheets. Just be careful how you do it. Just make sure you show your work.